Capacitors in parallel. For the purpose of this discussion, I'm going to assume that you are familiar with this stuff, so I don't have to explain any of this to you. Q equals CV. Here we have two capacitors in parallel, C1 and C2, and they're connected to an electromotive force. What's going to happen if we close this switch and allow current to circulate and bring electric charge to these capacitors? Well, these two capacitors are going to behave exactly as if they were one single capacitor, which we're going to call CEQ, the equivalent capacitor. That CEQ will have an equivalent charge, QEQ, and while these are the real physical capacitors, they behave exactly the same way as if you have a single fictitious capacitor if you pick exactly the right numbers so that this circuit matches that circuit. So how is that going to work? Well, first of all, we should know that whenever things are in parallel, they're going to have the same potential difference. So V1 equals V2 on capacitor 1, capacitor 2, and that's equal to the EMF because they're all in parallel. So that's something you should always remember, that things in parallel always have the same potential, regardless if they're capacitors or resistors or anything else. But you really shouldn't have to memorize that if you just understand what's going on. If you remember that a conductor is going to have a virtually constant potential anywhere throughout, so this conductor across the bottom has constant potential, conductor across the top has constant potential, then pretty much automatically the potential difference between these 2 points is the same as those 2 points, is the same as those 2 points. And of course the potential difference there is the same as right between those 2 points. So the EMF is also equal to the equivalent voltage that we have over on this imaginary capacitor. And since everything's equal, we can just put all those together. V1 equals V2 equals V equivalent. Now, what else can we say about this? Well, let's think about what happens when we close the switch. If we start out with 0 charge in these capacitors, current will flow from the electromotive force onto the capacitors. You get some charge on C1, some charge on C2, and some charge over here. So what's what? Well, here's what's what. Q1 plus Q2 equals Q equivalent. How do you know that? Well, think of it this way. A certain amount of charge has to cross from one side to the other of this switch. And there are ways to measure that charge. An ammeter would do it. I suppose there are other ways. So however much charge comes across here, it has to go somewhere. It's either going to go there or it's going to go there. So there's a certain amount of charge Q1 here and a certain amount of charge Q2 here. Now over here, the same amount of charge has to go across. Remember, this green stuff is the imaginary part, but this is still real. So this right here is going to have exactly the same current, exactly the same flow of charge that we had here. But these charges have only one place to go, which is right there. So the total charge must be the same in both diagrams. So the total over here, Q1 plus Q2, must be equal to whatever the charge was on that right there. And this is something that if you understand it, again, you don't really need a formula. It's just counting. It's like we've got a bunch of charge. Some's there and some's there. You put it all together, it's over there. It's like if you have 3 apples and 5 apples, you put them together, you have 8 apples. You don't need a special formula for apples and a different formula for oranges and a different formula for bananas. It's just counting. Got a bunch of stuff, put it all together, there it is. So there it is, Q1 plus Q2 equals Q equivalent. And last but not least, we have capacitance. How do we determine the equivalent capacitance of this new imaginary capacitor? We can actually use the results from here together with Q equals CV. Q equals CV means that, well, Q1 is C1 V1, Q2 is C2 V2, and Q equivalent is CEQ VEQ. But we already know that these V's are all the same. So we can simplify this expression by just dividing everything by V. Divide the left by V, divide the right by V. As long as it's all the same V, whatever that number is, does not matter. It cancels out. V cancels there, cancels there, cancels there, and you are left with that expression right there. C1 plus C2 equals C equivalent. If you like this, hit the like button and subscribe. Thank you for your time.